Oh, hello viewers. In this video, we'll be looking at the natural exponential functions. So we'll start with the number e. So what is number e? The number e is defined as what? As the value of this sequence here, 1 plus 1 over n to power n as n becomes very large. So in calculus, that is the idea of limits, actually, because if you look at this, if we take n, substitute n to be 1 into this, you will have 1 plus 1 over what? 1 all to power 1. This will give you 2 to power 1, which is just 2. So that's how we have this. If we substitute n to power 5, it's going to be 1 plus 1 over 5 all to power 5. And this should give us 2.488. So continuously, you will see that by the time we substitute n to be 100, you will have 2.70. But substituting n to be 1,000, it's 2.7169. Now, if you fast forward to when you substitute n to be 100,000, we have 2.718. So you can see the difference between this is almost the same number, right? Even though we jumped from where? From 100,000 to 1 million. So it means that the sequence 1 plus 1 over n, it will approach a what? A number. It come closer to this number. And this number is what we call the e. And the approximate value of that e is 2.71828. So this is what we call the number e. The number e is just this approximate value. It's just like pi. Okay, so as s now, even if you take s to be 1 trillion or whatever, no matter how large n becomes, this value will not change much. So it means our sequence or this function is approaching this value as n becomes large. All right, so now that we know what is e, let's talk about natural exponential function. So we know about what? We talked about the exponential function to be a to power x. And we said a can be greater than 1, right? But a cannot be equals to what? 1. So meaning we can have a to be between 0 and 1. But if we look at exponential, since e, so we can have this one. If we change this a to become e, so this is what we call the natural exponential function. And how does the graph look like? It's similar to what we've discussed before. So you can see, we know that e is 2 point something, which is between what? Between 2 and 3. Now, since it's between 2 and 3, and remember, we talked about this graph. This is an increasing graph. So we say, for example, this is 3, let's say 3 to power 2 to power x, right? And this is going to be 3 to power x. So because the a's are all bigger, so the bigger the a's, the closer the value to the y-axis, right? Okay, but now since we have e is between 2 and 3, it means that this graph is going to be here. It's going to be between 2 and 3, somewhere here. So this is going to be our e of x. So it's an increasing function as well. So here we have to evaluate these functions given these values. So if you want to find just f of what? F of 1. What is f of 1? F of 1 is just e to power minus 3 times 1, which will be e to power minus 3, which is just 1 over e to power 3. And we can also have f of minus 1 over 3, which will simply be e to power minus 3 times minus 1 over 3, And this is just going to be e. Minus will go with minus, 3 will go with 3. So this is e to the power 1, which is just e. Then we can have f to the power minus pi, which is just e minus 3 times minus pi, which will just be 3 e to the power 3 pi. So there's, now let's talk about the sketching. So to sketch this graph, we have to use, for example, we want to use the graph of e to the power x to sketch this graph and finding the domain and the range. All right, so here, what can we do here? If we start with the graph of ex, this is 0 and 1. And then we can do vertical translation 2 units to the left. And that will lead us to this one. So here will be 2 units to the left. Here will be minus 2, right? So we will have something like this. And this point is minus 2 and 1. And then finally, we have to do, no, this is horizontal, not vertical. Okay, this is not responding. All right, yes, now we have it. It's horizontal translation. Okay, now we do vertical translation now, 3 units down. Downward. So what does that mean? It means the value, remember this point is what? Is 1. So if you put it 3 units down, it will come to where? It will be somewhere here. If you move it down 1 unit, it will be at 0. Another unit, it will be at minus 1. So here will be at minus 2, right? But here will still be at where? At minus 2. So it's going to cut, and our horizontal asymptote is still minus 3. So this is y is equals to minus 3. So the graph will cut somewhere here. And now it will keep going, right? So here we need to know what will be our x-intercept. Or let's find the y-intercept first. Y-intercept, simply by putting x to be what? 0. So it means you will have f of 0 is going to be e to power 2 minus 3. So this is e to power 2. Remember, e is what? E is 2.7. So if you square it is going to be close to 9, right? So what we know is that this number is positive, and it's positive. So this is, it means we have to cut the what? We have to cut the positive y-axis. So this point is going to be our y-intercept, meaning that when x is 0, this point is going to be e squared minus what? Minus 3. Okay. And also we can find we can find the x-intercept actually. So what will be the x-intercept? X-intercept, you put y is equals to 0. So if we substitute y is equals to 0, you will see that we have 0 is equals to exponential ex squared minus 3. And then this becomes 3 is equals to ex plus what? Plus 2. Now here, since the bases are not the same, what we can do to solve this, we're going to discuss more of this in the next section. We can take log to base e of both sides. So if you take log to base e of both sides, this and this will go. So we will have that log to base e of 3, it's equals to x plus 2. So x is going to be log to base e of 3 minus 2. And what it means is this we can write as as log to base e is actually called ln. So we have ln 3 minus 2. So this is our x-intercept. We're going to discuss more about this one, this ln, when we get to the next section. In our next video, actually. So it means that this point is actually ln 3 minus 2 here. The x-intercept is ln 3 minus 2. So x-intercept is ln 3 minus 2. All right. So we can do with this. Now we are asked to find the range. I think we can get everything we need, actually. We just need the domain. The domain is still the whole of R. Nothing changed. But the range is what? The range is from -3 to infinity. Right. So for this one, we'll follow the same procedure here. You can write this as what? We can write this as minus e minus, then we have x minus 1 plus 2. So let's start with the graph of e to power x, which will be this one. This is the graph of e to power x. Then now, because of this minus, the operation, we're going this way. Because of minus, here we can do reflect. We can reflect across the x-axis. We reflect across the x-axis. It means we will have something like this. This is reflection across the x-axis. So this is now minus ex, right? Okay. Then we can now reflect across what's y-axis. Because of this minus now, reflect across the y-axis. We reflect across y-axis, we should have something like this. This will just be like this. Okay. So, but this point is what is -1 because reflection across, you can do it here, just this one, this side. Okay, but let's remove it. So now what is this graph? This graph is actually minus ex minus x. Okay. Now we have to move how many units? Because here you can see it's a minus now. Since it's a minus, we have to go to the right. So this will be horizontal translation, 1 unit to the right. So what does that mean? It means that this point will have to shift. So this point will shift somewhere here. And now it will be x is equals to 1, y is -1. So this is the shifting of the point. All right, so what is the last thing to do? Is we need to go +2, right? So +2 means you have to do horizontal translation. So here, not horizontal, vertical translation, 2 units upward. So if we do that, we will end up having something like this. Let me do it here. This is a final graph. Now, this is minus 1. If you move it 2 units, if you move it 1 unit, it will go to 0. Another 1 unit, it will go to 1. So this point is minus 1. Yes. No, this is the value of y. So this is point is 1 because the value of x remain. So this is actually 1, 1 here. 1, 1. And now you will have the horizontal asymptotes is still at where? At 2. So we have it cut in this way. This is the horizontal asymptote. So, but now we also need to know what is the x-intercept and the y-intercept. X-intercept, y-intercept, we can quickly calculate that. So let's see what of y-intercept. It means you put x to be 0. Put x to be 0, you will see that g of 0 is just minus 0, so it should just be 1, right? Yeah, then you have plus what? Plus 2. So this is nothing but 2 minus what? Minus e. That is the y-intercept. Because we just put x equals to 0. Put x equals to 0 here. You have minus 0 plus 1 is just 1, right? So you have e to power 1, but there is a minus. So it becomes 2 minus e. But now if you look at this, definitely 2 minus e is going to be a negative number, right? Because e is 2 point something. So what that means is let's find the x-intercept too. We might need it. So x-intercepts, the x-intercept now, you need your y to be 0, right? So you will have 0 is equals to minus also plus 2. And just like we did before, here it's going to be minus 2 is minus x plus 1. And then the minus will go with the minus. So we have this. Here also you need to take what? You need to take the logarithm of it. Okay. But do we really need the x-intercept for now? Because we're only interested in the domain and the range. But to find the value of x, what do? You take the log. This is where we stop. You can take the logarithm of both sides. So this is log to base e of 2. It's just going to be minus x plus 1, right? Because if you take the log to base e of both sides, log to base e of e will go. So it means that what? X is just 1 minus ln 2. Because log to base e of 2 is equals to ln 2. So what can we see? We can see that this means that the graph is cutting the y-axis. Remember, this is negative. So it has to come and cut somewhere here. It has to cut somewhere here. So this is our negative y-axis, and this is our positive x, our negative y-intercept. What is the y-intercept? It is 2 minus e. And what is the x-intercept? It is 1 minus what? Ln 2, which is positive. But what do we need from here? We need the domain. So the domain is still the whole of R. And the range in this case is what? Is minus infinity to the horizontal asymptotes, which is 2, all open. All right. So let's look at this one, number 3. Number 3 is we want to sketch the graph, but here now you can see the absolute value is outside. So let's start with what is inside. What is inside, we can rewrite it as what? Minus exponential x minus 3 plus 1. We can write it as this. So what do? We start with the graph of e to power x, which is this one. Here is 1. Then because of this minus, we have to do what? We have to do reflect across the x-axis. Once we reflect across the x-axis, then we will have this one here. Okay, so this is minus ex. Then the next one is we do ht, horizontal translation, 3 units right. So what that means is that what? This point here, we have to take it to the what? We have to take it to the right. And how do we take it to the right? It means it's going to move. So instead of 0 minus 1, it's going to be here. Moving to the right. So here is what? Here is 0 minus 1. So if you move it to the right by 3 units, it means it's going to be somewhere here. And what will be that? That will be 3 and what? Minus 1. So this is how it will cut. So we are here. Then we will have something like this. Something like this. So this is going to be E. No, this is minus E x minus 3. So finally, we just need to what? We just need to go 1 unit down. Now this is what? This will be horizontal, no, vertical translation, not 1 unit down, but 1 unit up. Okay, so if we do that, what do we have? This is minus 1 here. The distance from here to here is minus 1. So if you take this up now, 1 unit up, it means this point will move to where? Will move here. So this point is going to be 3 and what? 0. So just move this up. So then you will have this line cutting at this point and will keep going, right? But what is the horizontal asymptote? Since you are moving 1 unit up, you see our horizontal asymptote is cutting at where? It's cutting at 3, 0. So it means you will have a what? A horizontal asymptote at y is equals to 1. So this is what we have here. Right. Yes, because it's cutting at y equals to 0. So the distance between where it cuts, the y value, where it cuts, and the horizontal asymptote is usually 1 unit. And we can clearly see the horizontal asymptote from here, right? So now this is what we have, okay? Now, what is this graph? This is the graph of what? Of 1e minus e x minus 3 plus 1, okay? Then finally, we can put the what? The absolute value. So now we have to reflect the part below the negative parts. Reflect the negative part across the what? across the x-axis. So what is the negative part? Remember, the negative part means this one. So you just need to reflect it across the x-axis. And finally, we will have something like this. This will remain. This will remain. Now here we'll just go up here. Okay, so this is what we have here. This is the absolute value of minus x minus 3 plus 1. So this is our solution. All right, so we're done, and we're asked to find what the domain. Remember, this is y is equals to 1. So what is the domain? The domain still remains as what? As minus infinity to infinity. Okay, we're not even state the interval. We're actually looking for the interval where it is what? The graph is increasing. But this point is 3, right? Yes. So we can still find, let's still find the range. The range in this case will be from where? From 0 close to where? 0 close to infinity, but increasing. Where is it increasing? Increasing is just from where? From this point, but now you have to put it open from 3 to infinity. Okay. So we're done. So this is number 1. This is number 2. And this is number 3. And finally, number 4. All right. So let's go to these exercises. It says, let f of x be this, then which of the following is true? So this type of question, you need to graph everything. Just graph the whole graph. Let's graph it. What is this? This you can see is nothing but actually 1 over what's e to power x plus 1. So we just need to graph this one because this is the same thing as 1 over e to power what's minus, you can do it this way, plus 1. Or if you don't want, you just graph this one. What is this? This is e to power x, right? So e to power minus x is just a reflection across the what? The y-axis. So it's just going to be this one, the black one. So now this is e to power minus x. Then you want to go 1 unit what? 1 unit up. So if we go 1 unit up, 1 unit up, vertical translation, it will just give us this one. Just take this point. This point is 0, 1. So it will just be this point here. So it will cut at this point. But now our horizontal asymptote is going to be the line y is equals to 1. But which point is this? This point now is the point 0 and what? 0 and 2. Okay. So let's see from here which one is true. What is the range? The range is from 0 to infinity. Is that true? Definitely not. Because the range, you can see, our range is supposed to be from where? From 1 to 1 to infinity. Now, the graph of f has no x-intercept, right? Is there any x-intercept here? Now from the graph, we can see it has no what? It has no x-intercept because we are looking for the statement that is what? That is false, right? So you see, this is true. There's no x-intercept. The graph has a y-intercept at 0, 2. This is also true, right? Because we can see the y-intercept 0, 2. The graph of f decreases on the interval minus infinity. This is true because the function is decreasing, right? It's decreasing on the whole interval. It's also true. The domain is also true. So the only statement that is false is what? Is the first one. So this is only the false statement. Every other thing is true. Every other thing, true option, okay? So the same type of question here. We want to see what is false, right? So we have to graph. And how do we graph this? This we can write it as we can actually write it as what? As 1 minus this. We can write this similar to what we did earlier. This will be minus x minus 2, right? Okay. Yes, so we can start with what? We can start with e to power x. So I'll try to just do everything here. E to power x is what? Is this one, right? Then now, because of this minus here, you reflect it across the x-axis first. So we are here. Then now we have to reflect it across the what? Across the y-axis because of this. So if you reflect across the y-axis, you're going to have this one, right? Now, once you reflect it, you have this. Then now you have to move it 2 units to the right. So 2 units to the right, it means you move somewhere here. You're going to cut somewhere here. So let's remove all of this. Okay. Okay. Now, remember we move 2 units to the right. So this point is nothing but 2 and what? Minus 1. And then we need to move 1 unit what? 1 unit up. To move 1 unit up now is going to be here. So this will be the final graph. It's going to cut at 2, because you are moving this point here. So it's going to cut here, somewhere here. But what is our horizontal asymptote? Our horizontal asymptote is still the line y is equals to what? To 1. So you have this one, this way. Okay, so the red one is our f of x. So this is our f of x. All right, so which of the statement is what? Is false? Okay, so how do we know? Now let's look at the range first. What is the range in this case? Remember, we're dealing with the red one. The range is, okay, the graph of f is decreasing. Is this graph decreasing? Definitely no, because this graph is rising from where? From left to right. So this is automatically false, yes? Now, this one is false, so let me just use f. The range is from minus infinity to 1. This one is true. The x-intercept of the graph is what? Is 2, 0. Yes, because remember, this is 2 minus 1. When you move up here, 1 unit becomes 2, 0. So this is also true. The domain is also true, minus infinity to infinity. The horizontal asymptote is y is equals to 1, which is true. So only only A is false, because this graph, as you can see, is going to what? It's going to increase. All right. Number 3, he said the range of the function, this. Now, To do this, we can graph this function. We can start with e to power. We can write this as, because of this minus, I can just write it as 1 over e to power absolute value of x, right? So what does that mean? It means this one, I can break it into two. If we break it into two, this will split it into piecewise, similar to what we did before. This is going to be when x is positive, and this is what 1 over e minus x when x is what, less than 0. Okay. And now, if you like, we can convert this back to what we want it to be. This, instead of 1 over e, this can be written as e to power what, minus x, right? When x is positive, or this is minus minus, so this becomes ex when x is what, less than 0. So we try to graph this one first. So to graph this, it will be piecewise. What is e to power minus x? Remember, e to power minus x is just the reflection of e. So this one is ex, right? And let's use this one. So the black one is what? Is e to power minus x. But we need e to power minus x when x is greater or equals to 0. So for e to power minus x, it means you're going to take only the positive side, right? So it means we have to delete this side. So it will just be from here going. Then for e to power x, x is less than 0, so we take the negative side. So it means we have to remove this and just take this part. So this one is ex, and this is e to power minus x. But everything put together is the graph of what? This is just the graph of 1 over e absolute value of x. Or you can call it the graph of e minus this one. It's the same thing. All right. Okay, now, which point is this? This is the point 0 and what? And 1. So now, because of this minus here, this minus outside this one. So now you have to reflect across the what? The x-axis. If you reflect across the x-axis, what do we have? It will just be something like this now. No, okay, this is the red part, and let's have the black part here. Now this point is still 0 and what? 0 and minus 1. And now we have to do what? We have to do vertical translation, 5 units upward. So if you do 5 units upwards, what will change? So if you move this 5 units upward, remember this is minus 1. 5 units upward is going to start at where? At 4, because this is minus 1. We're talking of the y value now. So minus 1 plus 5 to be what? To be 4. So it means it's going to cut here. This one will go this way, while the black one will also go this way, right? All of them starting from where? From this point. But what is this point? This will be 0, 4. But what is the horizontal asymptote? The horizontal asymptote is y is equals to what? Equals to 5. So we still have this going. So y is equals to 5, like this. Yes. You see, the distance between where it cuts and the horizontal asymptote is usually 1 unit. So if it cuts the if the y-axis or the y-intercept is 4, then definitely the horizontal asymptote will be 5, which is evident, obvious from here as well. So this is the graph. And you can see now we can find the range. The range is nothing but what? The range is from where to where? Okay. It's simply from 4, because we're here, right? So it is from 4. The value of y here is 4. And here is what? Is 5. So the answer should be E. So the answer is E, not D. Okay. All right. So let's move to the next one. Here we have that what? The graph of the function, this, is decreasing on, here we are looking for where it is decreasing, so we'll have to sketch. So let's start with the inner graph. So this is minus e to the power minus x. So what does that mean? It means if you have the graph of ex, which is this, you reflect x and reflect y. So reflect x, we're starting with the graph of ex. So this is the graph of ex. And this now we reflect what's, we reflect across x. We reflect across x. What do we get? This will be this one. And then reflect across y. So let me reflect across y now. So this is reflect across x and reflect across y. So reflecting across y, let's do this here. This will be something like this, the black one. And then we go how many units? We go 4 units upward. So, but look at this point, where are they meeting? Both of them are meeting at where? At 0 and minus 1. So if you take this one upward now, this is, this black one here is minus x. And now we have to go horizontal translation 4 units up. So 4 units up, what does that mean? It means that this point will go up. How many units? 4 units. Remember here, the point here used to be 0 and what? Minus 1. So if we move it minus, so the y value, right? So minus 1 plus 4 is just going to be at a point 3. Right, so it's going to be something like this. Okay. Now, what is the horizontal asymptote? The horizontal asymptote still stays as well as y is equals to 4. Okay. Now that we have this, so what can we do? Remember, we need to know what is the x-intercept because there is a full absolute value. Everything is inside the absolute value. So now we need to know what is this x-intercept because here we're actually going to reflect this part across the x-axis, right? Because we have absolute value there. So if we reflect it, let me see here. We reflect this across, we will have just something like this part. So this is reflection across the x-axis because we don't want the part that is less than 0 because of the presence of the absolute value. So this is our final graph. Is just going to be something like this, and like this. And here you have y is equals to what? 4 as the horizontal asymptote. But the question is asking for what? Where the function is what? Decreasing. So as you can see, the function will be decreasing from where? From here until it gets to this point. Then here it will start increasing. So this line is our decreasing. But we need to know what is this point, which is actually the x what? The x-intercept. So we can find x-intercept. And how do you find x-intercept? You put y is equals to 0. So if you put y is equals to 0, what do we get? We get 0, it's equals to, yes, so we have 0 is absolute value of what? Minus e minus x plus 4. So if you have an absolute value to be 0, it simply means what is inside the absolute value has to be 0. So you have this one. Okay. And now we need to solve for x. If you want to solve for x, we can use our logarithm here. So this is minus 4 is equals to minus exponential minus x, right? So here, minus will go with minus. So you have 4 is equals to exponential minus x. So again, since this one is not what? The bases are not the same, you can write this as 4. You can take log to base e of both sides. So you can have log to base e, right, of 4 equals to log to base e of what? E minus x. And what will this be? This log to base e will cancel. So you just have log to base e of 4 is equals to what? Minus x. In other words, x is what? Minus log to base e of what? Of 4. And here we can also use the properties of logarithm, which we will discuss later. So you can, yeah, we'll discuss it in 4.3. This, remember, log to base e is the same thing as what? Is the same, or you can leave the, you can see this as log to base e of what? 2 power 2, right? Because 4 is 2 to the power 2. And one of the laws of logarithm is that what? This 2 can come down. So that becomes minus 2 log to base 2 of what? Log to base e of 2. Yeah. But this x is what? Minus 2. What is log to base e? Log to base e is the same thing as ln. So this is just ln 2. So you see, it means our x-intercept here is nothing but minus 2 ln 2. So if we are looking for where the function is decreasing is going to be from minus infinity to this point. So A is the right answer. Okay. So here we've used something that logarithm. So you can check my next video for more about logarithm here. So now let's solve this number 5, this one here. Now for this one, we just want to find the value of k. So we're given that e to power k minus 1 is equals to 1 over e to power 4, right? Then k plus 1. We can write it. But this is e k minus 1. And this also is going to be e to power. This is, you can break into minus 4, right? Yes, because e to power minus 4 is the same thing as 1 over e to 4. So this is e k minus 1 is equals to, now you can multiply the power. So you have e, this would become minus 4k minus what? Minus 4. Now we can drop the powers and just take k minus 1 is equals to minus 4k minus 4. And we can solve for k now. This will be k plus 4k is equals to minus 4 plus 1. And this will be 5 what? K is equals to minus 3. So k is minus 3 over 5. Okay, yes, so we're done with these questions. So I hope the video is helpful. You can put your questions in the comment section. And if you are new to my channel, you've not subscribed, kindly do that and turn on the notification bell so that you can receive my other videos. Thank you once again for watching.
One Ghanaian footballer versus one Nigerian footballer. So we'll be starting with Mohamed Kudus versus Samuel Chukwueze. So drop that like, drop that follow. 5-5. Mohamed Kudus. Cross. Scissors kick, bro. Scissors kick, broski. What a goal from Kudus, bro. What a goal from Kudus, bro. Coming in with the scissors kick, broski. Ooh. Very good finish from Samuel Chukwueze. Coming in with a volley, bro. Very good finish for him, but I'm giving this one to Kudus, bro, because Kudus was the next. So Kudus, the volley. Very good finish from Kudus, bro. Very good finish from Mohamed. What? What a finish, bro. What a finish, bro. So Chukwueze, fake shot, see that guy turn around. Broski, what a finish. What a finish, bro. See that guy turn around with that fake shot, bro. Very good finish for Chukwueze, and I'm giving it round to Chukwueze. Let's go. Mohamed Kudus. What a Kudus, bro. He's going to go solo, bro. Ooh. Hey, bro. What a finish, bro. What a finish for Kudus. So Chukwueze. Broski, what a finish. What a goal and what a finish. Very good goal from Chukwueze. But I'm giving this one to Cruz. Let's go. Very good finish from Mohamed Kudus. What? What a finish. So Chukwueze